Hey guys, it's Cody here, and this time we'll talk about spatial figures. Spatial figures, or three-dimensional figures, are figures that have depth in addition to width and height. Everyday objects such as a tennis ball, a box, a bicycle, and a redwood tree are all examples of space figures. Some common simple spatial figures include spheres, cones, cylinders, cubes, prisms, and pyramids. In a spatial figures, there are three parts, namely the vertices, edges, and faces. So vertices are the points where the lines meet. In this example, in a rectangular prism, the vertices are this, and this, because these are the points where the lines meet. And those lines are called the edges. The edges are the lines which forms the structure of the spatial figure. And lastly, the face. The face is the flat surface enclosed by the edges. So in total, in a rectangular prism, there are 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8. There are 12 edges and 6 faces. In a sphere scenario, there are no vertices, there are no edges and faces. So let's start. In my drawing, I'll explain to you. The bold lines or the curves are the lines which you can see in your view, and these dotted lines are the lines which you cannot see in your view. So let's start with sphere. Sphere is a spatial figure having all of its points the same distance from its center. The distance from the center to the surface of the sphere is called its radius. So this is a sphere. If this is the center and its measurement is 10 centimeters, from the center you move the 10 centimeters every direction to this, to everywhere, and it will form a sphere, a three-dimensional sphere. And the length from this point to this is called its radius, the half of the diameter. So that's the sphere. Next is the cone. A cone is a space figure having a circular base and a single vertex. If r is the radius of the circular base and h is the height of the cone, then the volume of the cone is 1/3 times the pi times r squared times the height. So this is a cone. So a cone, this is the circular base, and these are the lines, and this point is called its vertex. A cone only has one vertex, so that's the cone. And moving on to the next spatial figure is the cylinder. A cylinder has 2 circular bases in the top and the bottom, and a circular flat surface. This is a curved surface, and that's the cylinder. This is the radius, and the line connecting the end of the base and to the end of another base is called its height. So that's the cylinder. The next spatial figure is cube. A cube is a square. A cube is a three-dimensional figure having 6 matching square sides. A cube is more likely the same as a rectangular prism, but only all of its base and faces are all squares. Moving on to the next is a prism. A prism is a space figure with two congruent parallel bases that are polygons. In this situation, this prism is called the triangular prism because its base is a merely triangle. And the prism's special characteristics, it has base, it has length, sides, and height. So to the next spatial figure is the rectangular prism. This is one of the most common spatial figures in the physical world. So rectangular prism, as I explained earlier, has vertices, edges, and faces. And it has special characteristics of length, width, and height. This is the length, this is the width, and this is the height. On to the next and the last example of my spatial figure is the pyramid. So, a pyramid is a space figure with a square base and 4 triangular shaped sides. And same as other spatial figures, a pyramid also has a base and the side and the height. So let's now move on to the next subtopic of spatial figures, the volume. The volume is a measure of how much space a spatial figure takes up. Volume is used to measure a space figure just as area is used to measure a plane figure. The volume of a cube is the cube of the length of one of its sides. The volume of a box is the product of its length, width, and height. So let's start with the volume of a sphere. The formula for the volume of a sphere is 4/3 pi r cubed. So let's substitute its values. So the volume of a sphere is equal to 4/3 multiplied to the value of the pi, which is 3.14, multiplied to the cube of the radius, 10 cube. Using PEMDAS, it gives us the result of 4/3 multiplied to the value of pi and r squared, which equates to 1000. Combining these three values equates to 4186.67, and its unit will be cubic centimeters because it is volume. Now let's try to get the volume of the cone with the formula 1/3 pi r squared height. The radius is 8 centimeters and the height will be 13 centimeters. Let's try to get its volume. So let's substitute the values of cone. So 1/3, and the value of pi is 3.14. R squared, the radius is 8 centimeters squared, and the height 13. Using PEMDAS, we'll first get the answer for the exponent, so 3.14. So let's get 8 squared, which is 64, multiplied to 13. So let's combine these two values, 1/3 multiplied to 3.14, and the product will be 1.05. Then multiplied to the product of 64 and 13, which is 832. Multiply these products and we will get the answer 873.6 cubic centimeters, and that's the volume of the cone. Next, we'll try to get the volume of the cylinder with the formula pi r squared h. In this example, the height given is 16 centimeters. So let's get the volume of the cylinder. Let's first substitute its values. So pi, which is 3.14, multiplied to r squared, and the radius, I'm sorry I forgot to tell you, but the radius is 5 centimeters. So let's go back again to the formula. So radius is 5 squared multiplied to the height, which is 16 centimeters. Using PEMDAS, let's get it to its whole numbers. So 3.14 as is, and 5 squared, which is simply 25, doesn't need a calculator, and 16. So let's multiply the value of pi to the value of r squared. So 3.14 multiplied to 25 is 78.5, multiplied to the height 16, which give us the result of 1256 cubic centimeters, and that's the volume of the cylinder given in my drawing. And the next spatial figure that we're going to get its volume is the cube, and the formula of its volume is the simplest: side cube, and the measure of the side is 13 centimeters. So let's get the volume of the cube. So let's substitute the value of s, which is 13 cube. So let's put 13 3 times. 13 multiplied to 13 times 13. 13 times 13 is 169. Multiplied to another 13, and the result is 2197 cubic centimeters. So that's the volume of our cube. And let's get the volume of the next spatial figure, which is the prism. With the formula of the volume, 1/2 times base times height times the length. In this prism, the base is 6 centimeters, the height is 5 centimeters, and the length is 10 centimeters. Now let's get its volume using the formula given. Let's get the volume of the prism. Let's substitute first 1/2 multiplied to its base, which is 6, multiplied to its height, which is 5, multiplied to its length, which is 10. So 1/2 base times height, which is 30, multiplied to 10. So now let's multiply these numbers. So 1/2 times 30 is 15, multiplied to 10. And the result is easy: 150 cubic centimeters. And that is how you get the volume of a prism. The next spatial figure is the rectangular prism, and its volume formula is one of the easiest ones, and it is length times width times height. In this figure, the length is 13 centimeters, the width is 4 centimeters, and the height is 8 centimeters. Now let's go and get its volume. So rectangular prism. Let's substitute its values. The length, which is 13 centimeters, the width is 4, and the height is 8. 13 times 4 is 52, multiplied to 8. And thus we'll get the result of 416 cubic centimeters. And 416 cubic centimeters is the volume of a rectangular prism given. And finally, the last example of our spatial figure is the pyramid. And let's get its volume using the formula 1/3 multiplied to b squared multiplied to its height. So in this example, our base will be 8 centimeters and our height will be 12 centimeters. So pyramid is equal to, let's substitute first the unknown numbers. 1/3 times b squared, our b is 8 squared and our height is 12 centimeters. Using PEMDAS, let's get its whole number from b squared, which will be 64 multiplied to 12. And 1/3 multiplied to 64 is 21.33. And let's multiply that to 12, which will give us the result of 255.96 cubic centimeters. And this number is the answer to the volume of our pyramid. So in summary, spatial figures are three-dimensional figures made out of vertices, edges, and faces. And its volume is the space provided by the space occupied by the spatial figures rather, and getting the volume is merely just multiplying its length by its width and by its height if it is made up of flat surfaces. And if you deal with circular faces like spheres, cylinders, and cones, you have to use the value of pi to get its volume. And that's it, guys. Hope you learned something from spatial figures and volumes. Thank you for watching.